Alright guys, so today we're going to be talking about chapter 23, inference about means, and it's from part 6, inference for means. So we're going to jump straight into the question. Suppose you have a sample size of 18. What is the t-score if you are looking to represent the middle 95%? So here we need to take a look at the degrees of freedom, the parameter that t-models, new model, or other than the normal model for means depend on. The degrees of freedom, in order to find them, you get the sample size, in which case is n, and then you subtract 1 from it. So if you have a sample size of 18, the degrees of freedom would be 17. Okay, so in this question, suppose you have a sample size of 18. What is the t-score if you are looking to represent the middle 95%? So again, our sample size is 18, and we are looking to find the middle 95%. So we need to do inverse t of the area and the degrees of freedom. In order to do that on your calculator, you would do second bars and then go to the icon that says 4, and it has inverse t and parentheses. In order to find the area that you need for the inverse t, you take 100% minus the confidence interval, which in this case would be 95%, so you would be left with 5% as the area. And then you find the degrees of freedom. Like stated before, the sample size in this problem is 18, so 18 minus 1 would be 17. So then that would leave you with inverse t, 0.025, and 17, with a t-score of negative 2.1098. Notice how this problem has 2 tails instead of 1. Usually we had done solely 1 tail per problem, but this point, since we're trying to find the middle 95%, we are using 2.5 and 2.5 on each side. Okay, now we're moving on to sampling distribution for means. The problem: to keep a scholarship, Waubonsee Community College recommends students take 12 credit hours per semester on average. A random sample of 30 students in a class of 500 find that they take an average of 14 credit hours with a standard deviation of 1.5. Is this unusual? The formulas for sampling distributions for means would be t equals y bar minus mu divided by the standard error of y bar, where the standard error of y bar is the standard deviation over the square root of the sample size. So keeping those formulas in mind, we have a mu of 12, a sampling size of 30, a y hat of 14, and a standard deviation of 1.5. Again, to keep the scholarship, Waubonsee Community College recommends students take 12 credit hours per semester on average. A random sample of 30 students in a class of 500 find that they take an average of 14 credit hours with a standard deviation of 1.5. Is this unusual? With a standard error of y hat, we have 1.5 over the square root of 30, which equals 0.2739. And then our t would be 14 minus 12 divided by the 0.2739. So then we would get a t of 7.3019. This leads us to think that it is highly unusual, since it is a 7.3019 standard deviations away from the mean. Usually we want to have a lower standard deviation away from the mean. Otherwise, the higher the standard deviation away from the mean means that it's more unusual. Now for one sample t intervals. A quality control expert at a drink bottling factory took a random sample of 9 bottles from a production run of 1,000 bottles and measured the amount of liquid in each bottle in the sample. The sample data was roughly symmetric, with a mean of 505 milliliters and a standard deviation of 6 milliliters. For this example, what is the 95% confidence interval for the mean amount of milliliters per bottle in this production run? So we have to check the conditions for this. The first condition would be random sample. Usually all of the samples are random, but if not, we can just assume that it's a random sample and continue with the problem. We have to make sure that the data is less than 10% of the population. Finally, we have to make sure that the data is nearly normal through a histogram or probability plot. If not, you usually should advise that in the future they should use a larger sample size in order to have that more accurate measure. So for this problem, we have y bar plus or minus the t-score with the degrees of freedom times the standard deviation over the sample size, the square root of the sample size. In this problem, we have n is 9, y bar is 505, the standard deviation as 6, and a confidence interval of 95%. We checked this for the conditions, and it is a random sample. The 9 bottles is less than 10% of all bottles in the production, and the data is roughly symmetrical, so it is nearly normal. When we solve this, again, we have the sample size of 9, y hat of 505, standard deviation of 6, and a 95% confidence. So the t-score would be interval t 0.025 and 8 for a t-score of negative 2.3060. We use this t-score to add it on to the y hat right here. And you add it or subtract it in order to find that confidence interval times the standard deviation and the square root of the sample size. We get a range of 500.388 and 509.612. So now we say, I am 95% confident that the mean amount of milliliters per bottle in this production run is between 500.388 milliliters and 509.612 milliliters on average. This right here, I am blank percent confident that blank between the lower bound and the upper bound that we found up here on average is the formula that you should use when making your conclusions. So now we're looking at one sample hypothesis t-test. The problem for this is apparently the average heart rate of Americans is 72 beats per minute. A group of 25 adults participated in an aerobics fitness room to lower their heart rate. After about 6 months, the group was evaluated to see if the program had significantly slowed their heart. The mean heart rate for the group was 69 beats per minute, with a standard deviation of 6.5. Was the aerobics program effective in lowering their heart rate? Here we have the P from phantoms with mu equaling the true mean of the population. The hypotheses, I guess, in this context would be HO with a mu that equals the given number from a source. And the HA would be mu does not equal mu 0, or mu is greater than mu 0, or mu is less than mu 0. The A in phantoms would be listing the conditions, which we went over before. The N would be naming the test, and in this case it's a one sample t-test. The T from phantoms is the given sample mean. Alright guys, so now we're going to do this, but we're going to have to wait until next video, so stay tuned for chapter 23 video notes part 2.